All right, so here we want to find the doubling time. So that means we want our money to be twice as much as it was at the initial investment made when you're looking at 7% interest per year compounded continuously. So we will start, because it's compounded continuously, with our PERT formula. And then we'll ask ourselves, what of these unknowns can we fill in? So the only number in the problem is this 7% per year. So that is going to be our interest rate. So let's go ahead and plug that in. E will be our 2.718 constant. Our interest rate will be 0.7. Now, we are trying to find the doubling time. So that means that our unknown here needs to be t. So we are trying to find t. But you'll notice that there aren't any other numbers, and yet we still have the a and the p variable. So here the idea is, if you start with p dollars, then your end amount, if you double it, is going to be that you end with 2p dollars. Okay, so think about it like if you start with $50, you double it, you're going to have $100, or 2 times 50. So what we'll do is we'll keep p as an arbitrary p, and we'll make a the double of p, which would be 2p. Now, at first glance, it might seem like, oh, I can't solve this because there's too many unknowns. Remember, we are trying to solve for t, and t is in the exponent. So our first step, because t, the variable of interest, is in the exponent, is we are going to isolate the base plus the exponent. Now, if I do that, my base of e and my exponent of 0.07t, that needs to be by itself 100%. And we notice currently we have p times that. So step 1 of our exponential equation to solve, we're going to start by dividing by p and dividing by p. And that will then cross out the p's on the right-hand side so that you just have e to the 0.07t. And on the left-hand side, what is so cool about this is now the p's cancel out on the left-hand side as well. So there goes our whole p variable, and now we just have one unknown that we're trying to find, which is t. So this will look like 2 times e to the 0.07t. Now, again, we're trying to get t out of that exponent in order to solve, so we will take the natural log of both sides. So I apply natural log here, natural log here. And the benefit of that is now I have natural log of 2 equals the natural log and e cancel each other out, leaving us with 0.07t. So to get t by itself, we'll just divide by 0.07, divide by 0.07. And that will give us t equals this natural log of 0.07, which we want to compute. And when we compute that, we will get 9.9. And again, as I said before, just be really careful when you plug this in on your calculator, because it's natural log. You end your argument, then hit the division button, then hit the 0.07. And you should find that t is approximately 9.9.